Welcome to the second part of lesson 2. Here we will be looking again at the origin of project and project selection, and we will continue the presentation from where we left in the previous presentation, in the previous video. Here we are looking at the financial parameters, and we will consider some of the, let's say, most used parameters. And they're not too complicated, but you have to know that in some cases, in some companies, there may be more complex parameters that will be used. The first element, which you may already have heard about, is the payback time. It's basically the time to recuperate the initial investment without considering discounted cash flows. Now, when we look at the previous slides where we had the table of the investment and the cash flows, we saw that the payback time was here somewhere in the 4th year. We can do that calculation. We will look at the formula in the following slides so you have an idea how to calculate this. Return on investment is basically the percentage return on the investment, also not discounted. Then we have the net present value. This is the expected profit, but we have the future cash flows discounted. So all the future cash flows will be discounted, which means that we recalculate, we discount those future values to their present value. And then we can compare the investment with the cash flows. And a net present value which is positive means that we expect a profit. The last term, the last parameter that I will be considering here is the internal rate of return. And the internal rate of return gives you the expected yield of the investment. And when we have an investment, we know that money has a cost. So there is a certain percentage that a company has to count as a cost for using the money, which is expressed as the weighted average cost of capital. Now, that's a calculation. It's part of financial courses, and some of you may already know it or you will learn it. But there is a second parameter, which is the required rate of return, or RRR. And the required rate of return is basically the WACC increased with a risk factor. When we have projects of high risk, we have to include a risk factor. And that risk factor is a few percentages depending on the company added to the WACC. And then we don't refer to the WACC anymore, but we refer to the RRR or RRR. When the percentage for risk is equal to 0, then the WACC and the RRR are equal. Let's have a look at the payback time, or the PBT. The payback time is calculated with the formula that we see here, and it's typically expressed in months or years. So the payback time is the initial investment divided by the monthly or yearly cash flows. Let us consider an initial investment of $450,000, which creates monthly cash flows of $10,000, and this will give a payback time of $450,000 divided by 10,000, which results in 45 months or 3.75 years. Now we can say, is this acceptable? Well, it all depends on the industry you're in. If you are in automotive, 3.75 years would be really great. It can be a lot more. I heard numbers of 15 years because the investments are really huge. And when you have those huge investments, it's clear that it takes longer to compensate the initial investment. Some companies use 3 years. It's something defined by the company and also defined per project. Some projects will be, let's say, compensated faster. They have a smaller PBT, while others, it will take longer. Another element is the return on investment, or ROI, and it's basically a percentage which we obtain by dividing the profit by the initial investment. And when we look at an example, I have an investment of $450,000. It gives at the end of the evaluation a profit of 510,000, not really a profit, I should say here a revenue of 510,000, that is better. And this will give an ROI of 510,000 minus 450,000, so the revenue minus the cost divided by the initial investment gives us, in fact, 13.3%. We can say the same thing or ask the same question, is this acceptable, yes or no? It depends on the industry you are working in, and that's the main thing that you have to consider. A more interesting parameter is the net present value. The previous parameters had some disadvantages because basically they did not take into account the time value of money. So basically all those cash flows that we considered, they were not discounted and basically they are too high. So we have a little bit of an overestimation of the payback time, a little underestimation of the payback time, and overestimation of the return on investment. The net present value is in fact a little bit different. We calculated by discounting the future cash flows and subtracting the initial investment. So what we are doing, we are calculating the present value of all the future cash flows, which is in fact the revenue of the project in present value terms, and we subtract the initial investment. You have formulas for this in Excel. There are some presentations where you can see that. You have to be careful if you use the net present value formula. You have to use the net present value based on the future cash flows minus the initial investment, and it's very important to understand the discount value. Watch the WACC. Typically, here I took x is equal to 5%, which would give me 1.05 to the power of I. The farther away from the completion of the project, the higher the value I is. Now, when we look at this and we say, okay, this is the investment we had before, and I didn't fill out anything in the second row. We're going to do that in the following slides. We're going to see what are the discounted values, what are the different values that we have to consider. So let's have a look at this example. Here we have an investment, still the same. We have the cash flows, and we have to calculate the discount factor. And the discount factor is for year 1 divided by 1.05 to the power 1, which is 0.9524. So that's the discount factor, and we have to multiply the cash flow with the discount factor to find the discounted value of the cash flow. It will always be lower, so be aware of that. If you find a value which is higher, something is wrong. We do the same thing for the 150,000. Here we find 1 divided by 1.05 to the power 2, which is equal to 0.9070. And we do the same thing for year 3. We have 1 divided by 1.05 to the power 3. And in the last one, we find 1 divided by 1.05 to the power 6. So we see the 6 relates to the year that I'm considering. And we see that for year 1, the discount factor is 0.9524, while for year 6, we have 0.7462. So you see that it's gradually going down, and the farther we go in the future, the lower that discount factor will be. Now we look at the discounted cash flow, and when we consider year 1, we have to multiply 75,000 with the 0.9524, which gives us a discounted value of 71,430, and that we can put in the table here. Now we can do the same thing, or we have to do the same thing for all the other years. So for year 2, we find 150,000 multiplied with 0.907, 0. It gives us 136,050, and we see, for example, year 3 and year 5, we see that the cash flow is the same. Now, because of the discounting factor, we see that the present value of the 200,000 in year 3 is 172,760, while in year 5, 2 years later, it's only 156,700. And that's clearly the effect of the time value of money. Now let's have a look at the discounted cash flows. When I add all those elements together, so the discounted cash flow of year 1 plus year 2 up to year 6, we find that the revenue is, the discounted revenue is 873,820. And in order to find the net present value, we take 873,820 and we subtract the initial investment, 500,000, which gives us a net present value, in this case a profit of 373,820. So that was the part, all for this second part of lesson 2, and in the next video we will look into the remaining elements of this class.